Welcome back to another episode of OpenInfra Live, the Open Infrastructure Foundation's hour-long interactive series featuring production cases, case studies, open source demos, industry conversations, and all the latest updates from our wonderful global community. We're live here on Thursday at 15 UTC, streaming to YouTube, LinkedIn, and Facebook. My name is Kendall Nelson. You may recognize me from previous episodes. I'm a senior upstream developer advocate at the Open Infrastructure Foundation, and I will be your host for the day. So today we're joined by experts from Oregon State University, Monash University, Telecom Paris, and also the OpenStack Scientific SIG to talk about how they use OpenStack in academia. So like I mentioned a second ago, we are live, which means we can be answering your questions throughout the show. So please feel free to drop comments, questions, musings, hellos, whatever you'd like into the comment section of wherever you happen to be watching this stream today, and we'll get to as many of those as we can. First off, I want to thank all of our member organizations, including Stack HPC as our silver member today, who all collaborate to make this show possible. A huge thank you to all of their support. And also as a side note, if you're interested in joining the foundation, please check out openinfra.dev/join to learn more. Quick bit of history background for this. Last year, the OpenInfra Foundation announced an associate category of membership for foundation members to recognize and collaborate more closely with academic and public research institutions and nonprofit organizations that use, build, or sustain open infrastructure. So all of the organizations joining today are associate members, aside from Stack HPC, which is a silver member, like I mentioned. So thank you to all of their support as well to help build the foundation's mission of open infrastructure. So without further ado, let's get started today. First up, we have Stig Telfer giving an update on the scientific SIG and how they advocate for research computing and open infrastructure. I'll let you take it away, Stig.
Hey, thanks, Kendall. So I guess we're here today because OpenStack is a killer app for academia, and you might wonder why. I guess it's because why does it work so well for research computing and academia? And I think if we go on to the next slide, you can see it solves a whole host of problems faced by modern academic research computing environments. And the kind of transition that these environments are going into, they're really being swept up by this sort of sea change in the way that research computing is being done today and looking forwards into the future. So I guess that the first thing that we look at is where have things been up until this point, and how do we adopt and embrace these new changes instead of getting sidelined by them. So we get these ideas in modern or current conventional academic research environments about silos of compute infrastructure, and where you might see dedicated hardware solutions, systems deployed for a particular purpose, very compartmentalized with bespoke and dedicated software stacks. We may well see that the software environments being deployed to these systems are the ones that the admins, the cloud, or the HPC admins provide for the researchers. The researchers very much get what they're given, and they do what they can with it. And finally, the other drawback of modern approaches to consuming academic compute infrastructure might well be that we're driven in a kind of a ticket-based system in which these very thinly spread research computing admins tend to be in the loop to affect any kind of change. And we can see how cloud and OpenStack and open infrastructure can really play a transformative role in solving these problems for academia. So we can bring about this kind of consolidation of many diverse compute platforms onto a common substrate of private cloud. Using that and automation and other intelligence brought in from cloud native techniques to bring about this kind of self-service environment where research computing doesn't have to be based on the flow of tickets coming through to a service desk, or getting these admins to do the bidding, because that really leaves people spread thin. If we can self-service these things, and if we can provide our users with environments that they have a greater degree of ownership, of authority over, everyone is tremendously happier. And this is really the promise that cloud is delivering for academia and research computing environments. Can we go on a slide, please? So, but it's not a complete shoe-in, I would say. Research computing is not really the same in every situation as a sort of a conventional cloud environment. A lot of assumptions about the way that people consume cloud don't match up with the ways that conventional scientific computing is done, and the way that infrastructure for scientific computing is managed. And so we have quite a lot of challenges in using OpenStack and adapting OpenStack to work well in this tremendously broad environment that is academia and research computing. It's highly diverse, and in some of the sort of the tip of the triangle, where we start to look at these really high performing supercomputer environments, a cloud can be incredibly powerful and transformative, but it really needs quite a bit of expertise and adaptation to make it work well in all of these contexts. And so furthermore to that, there's a huge body of conventional wisdom about how research computing infrastructure in academia is installed and operated and managed and reconfigured. Cloud is just such a different mindset and a different skill set to all of that. And so we have, as well as the solutions, we have a great deal of problems to overcome. And the great drawback to this would be these learning curves are just enormous. And if we were solving them in isolation, in many cases, they may well become insurmountable. Next slide, please. So I guess that's where the scientific SIG comes in. And the idea here is that it's a collaboration, or a sort of a loose affiliation of different research computing institutions, members from around the world. These aren't competitors. I mean, certainly not at the admin level. I mean, there's academic competition, but for the people running the clouds or creating these systems, everyone is a fellow traveler. And this creates a somewhat unique and tremendously cooperative atmosphere within the scientific SIG. There's no de facto opinion on the right way to do things. There's a huge amount of diversity in the solutions, but there's plenty of fellow travelers who have the same problems to solve, and so it brings about this kind of nice, rich discussion. People bring in information, and generally it's a great forum to go and find answers about how to address the problems of research computing using the solutions that OpenStack and private cloud can offer in return. So one of the things I would like to say is that if you're interested in the scientific SIG and the way that the scientific SIG solves these problems for OpenStack today, look out for the book, The Crossroads of Cloud and HPC, which is freely available from the OpenStack website, and has 7 chapters which cover different case studies, different topics around how to solve research computing and academic challenges using open infrastructure. And it's a tremendously good tool for this. So today, in the age of COVID, the scientific SIG is a Slack channel, and it's free to join. I didn't post a link here in case it got overwhelmed with other stuff, but I think if you can find us, it should be easy to reach out, and we'll happily give you a link. There's one, I think, on the scientific SIG's wiki pages on the OpenInfra website. Mostly what we do is to bring about this advocacy around the scientific SIG, and to talk about how to use research computing so how to use OpenStack for research computing use cases at OpenStack conferences, but also conversely at high performance computing conferences and scientific computing. Mostly we get about through the Slack channel, we have weekly IRC meetings, which tend to also go ahead. But the real inspiration or the real output and the real bonus of the scientific SIG is either in the PTG where we do lightning talks, or at the OpenInfra summits where we tend to get together and have a few hours sharing information and talking over stuff, and usually a good social occasion as well. It's a very friendly group, covering all aspects of academia and research computing, and I'd be very happy to see you there. We have about 150 members, which is, I mean, it's just tremendous actually to see this group of people reaching out and helping each other in this way. I think probably I should stop there and actually get onto some real academia use cases.
Well, I don't know. I think that you've done a lot of work setting the groundwork for everyone else and being there as a resource for them. So I love attending the scientific SIG sessions because I feel like I learn something every time, not just about OpenStack, but science and research in general. So do you happen to know which time slots you have for the PTG that you're signed up for people interested in attending?
For the PTG, I don't know at the moment.
Okay. Yeah.
I'd have to get back to you on that.
Yeah, it is a free event, and it'll be the week of April. Oh, man, I gotta look at a calendar. I believe it's the week of the 11th. Numbers. Oh no, I'm wrong. April 4th. I'm looking at the wrong month on my calendar, but we hope to see you there. And obviously the scientific SIG will be there, and hopefully a few others. I know the scientific SIG, you collaborate somewhat closely with the large scale SIG, given the amount of data that you process in these research projects. Did you want to talk a little bit about that SIG as well and how you work together? Or
so we've definitely had some good discussions around how to manage large scale infrastructure. I think in the context I'm aware of, large scale bare metal is another one. So there's a good deal of alignment with the bare metal SIG as well. So managing the sort of the high performance computing resources of a university usually involves managing hundreds or potentially thousands of systems in a bare metal cloud, and so that brings about some great challenges and great benefits too.
Yeah. And the other group that you collaborate with are the OpenStack operators, obviously being mostly operators yourselves. Do you know if there are any upcoming meetings for that group at the PTG or maybe in Berlin?
Oh, not that I'm aware of. I haven't even started to think about the Berlin schedule yet. So no, well, I'm sorry, I don't know yet, Kendall.
It's totally okay. We'll talk a little bit more about Berlin towards the end of the show. So thank you so much for this overview. It's been great, and we'll have you back towards the end for more questions. So next up, we have Steve Quinnett to talk about why Monash E-Research Center at Monash University uses OpenStack. Hello, Steve.
Thank you, Kendall. We might as well move on to the first slide. So I guess the question we've been asked is why use OpenStack in academia? And I thought perhaps the one thing I could do amongst my peers here is answer or ask the question is what's the value of OpenStack to a university? And for all those at a university, they're complicated places. I could answer simply and say, I'm a cloud builder, I run a facility, and so on and so forth. But what I want to convey through these set of slides is something about the complexity of universities and academia, and why that makes sovereignty over digital things really important. And so, just to make to explain it a little bit, I live in a business unit of the university that's about research. It's the research office area, research infrastructure area. But most of my staff have they're IT professionals, they're IT people, But we have a shared vision and drivers. Um, and they're really these 2 bullet points. One is that researchers are connected. They're not really living inside the campus, inside the institution. They're connected everywhere, and I'll explain that in a tick. And the other is that even if you just use Excel and you make a spreadsheet, you're programming something, you're creating technology yourself as a researcher. And what we're really dealing with, and Stig was alluding to all these things, is intrinsically researchers need advanced computing. They need to be pushing the boundary, and I'll talk about that as well. And so our job in the university is to consolidate those styles of research needs, and do that in a manner that delivers the greatest impact to those researchers in the universities and mankind. But we're cash constrained. It's with the dollars that we actually have. Next slide, thanks. And so just to talk about this connected world angle, and I always point people to the website below. It's research.monash.edu. And there's some key stats at the very top. And that is over the last 5 years, we've had in the order of 5,000 researchers and 26,000 projects. And if you look at that map, it points to 60,000 connections around the world. And the challenge that we face as universities is, well, it's easy to go and have an IT process to control everything, and everything's a form. But that's hard to do when you've got 20,000 projects, 80,000 connections around the world, 5,000 researchers. So we need to be able to scale up and not impact the rate of those connected people. So this world is intrinsically connected, and they bring their own technologies along into that collaboration. So if we can move on to the next slide, what we started to realize, and this was in the order of 10 years ago, was we needed to enable researchers to work on projects together as they emerge, wherever they want to take it. And so we created this federated research cloud. It's called the Nectar Research Cloud in Australia. It's now hosted or funded by a thing called the Australian Research Data Commons, who are also members of the OpenStack Foundation. And we did something really innovative. We made it really easy for researchers to get a resource anywhere in Australia on any one of these nodes. But we did things like centralize some of the things that we need to do. Then my group then got involved with banks, researchers doing stuff with banks, and we needed to secure the information we got from sensitive information and prove we can do those things. And what we noticed out of that today, that still is a culture of data privacy, of data classification, asset identification, and safe havens or enclaves or whatever your favorite word is, processes that make sure that people keep their promises. We've had a lot of researchers, and we were very early on, and we pushed the OpenStack community to get GPUs working in OpenStack. It didn't work when we first started. And that's been really important because most research need is visual when they need to interact with things. And so we end up with communities creating their own platforms, either VDI based and now very much Kubernetes and everything based. And so that bringing GPUs into the foray and helping research groups create those platforms is really, really important. We also got involved with the HPC community, and now we have a HPC built on top of our OpenStack, and we've had that for a very long time, by being the first to bring HPC style NICs into the cloud space. And in more recent times, I've been working a lot with NVIDIA. We're in around DPUs and smart NICs and looking at how we encrypt and do all these, whatever your CISO's or CIO's favorite security tools, offload them so that the researcher doesn't have to do them. They get done in the background, but also they don't lose resource. The security is not taking cycles away from them. So these are all things that we're doing to consolidate the needs of the researchers, and that we need this language that lets us pool everything and be efficient. And that's where really OpenStack comes in. So just on my final slide, thanks. So just if I could tease that out a little bit, one of the things that we're noticing is that research priorities across the globe, they're trending towards society and translation. And, you can sort of see that as the idea of the lab is sort of trending away from being a room where there's a microscope to being the whole campus, the university, the being of a university. And so there's this sovereign idea of needing to own how technology works, right? And here's a really anecdotal example. It's come up recently. A local cloud provider who claims to be net zero aspiring, very close, really, really good stuff. And they say, oh, they're 25% cheaper than the hyperscalers. Okay, well, that's interesting. That's good. At the scale that we do things across all the loads, we're in the order of 5 times cheaper than those hyperscalers per workload. And that's been that way since 2014. But what's really interesting, as soon as A100s, a rack full of A100s or something, GPUs get involved, that ratio comes down to about 3 times. And why is that? And that's because the energy density is so much higher and our power bill goes up so much further. Our operating expense is much further. And we've got another thing where the university is really interested in being, and it's got a target to be net zero by 2030. So there's a tech problem here, but it's actually a research culture problem. If one of the advantages of OpenStack and owning the whole stack all the way down is we can start to tackle this problem. We can look at how does the university get the greatest value, keep the high rate of cheapness or dollars per capacity, but also go net zero, because we could be working with the technology providers to do that and all sorts of bits and pieces. So I'll just leave you that food for thought. And the value of OpenStack is many things. It's not just technology. It gives us the ability to be a university. That's it, Kendall.
Awesome. Well, thank you so much for all of that. And also thank you for being awake in the middle of the night, because I know it's not an excellent time zone translation for you right now. But yeah, thank you for being here. So I have like 2 little questions. One, or a question and a comment. One question, you had mentioned like GPUs. What sort of work did like Monash University or you specifically do to help like drive those efforts of getting that implemented in OpenStack?
So back then, I think it would be fair to say we were too afraid or something, or anxious to get too much into the OpenStack code, and we very much aligned ourselves with the user community and brought use cases and together with the vendors and OpenStack helped drive and validate the code that was going on and back then. So it was a very user-centric contribution that we made back then. And then probably just benefited from being one of the first public entities that could publicly say, hey, we're doing this.
Yeah. Even that sort of contribution is huge and super helpful for the people that are working upstream, because like you don't know as a developer all the ways that the code is being used. So any feedback like that from users and operators is so helpful, which is why we have things like the forum at the OpenStack Summit or Open Infrastructure Summit that's coming up in Berlin. So the other kind of follow-up question that I have, I know in the more recent releases, vGPUs have been a thing that have been implemented in Cyborg and Nova. Have you been tracking that, interested in that? Is that going to help at all?
Yeah, definitely. And the ARDC has to help drive and push that along, create that step change, be the market failure fixer. ARDC has come in and funded for capacity for dense GPUs and virtualizing it, and really helping us enable, getting us to that point where we'd get GPUs through Kubernetes at scale as well, and all those bits and pieces. So yeah, definitely, and all those things, the same things occur. We've got applications that we help drive, and test and validate those things. And the ARDC folk in Nectar, there's a group called Core Services. and several of those people there are active contributors into Nova and other things like that as well.
Awesome. Cool. Well, thank you so much again. I know one other side note, there has been like a group of people talking about forming a SIG more at like the foundation level rather than OpenStack specifically, around like net zero sort of things, and like being more aware of the impacts on the environment of these, you know, huge clusters people have and that sort of thing. So hopefully in Berlin we'll have something forming actually concretely. There was an article from the BBC recently that went out about how they track their emissions and stuff. So maybe there's some collaboration there to be done as well.
That's brilliant. I'd love to talk to them.
Awesome. Cool. Well, thank you so much. I will bring you back on in a little bit. So I have had the pleasure of working with our next guest for a little while now. Remy and Mark at Telecom Paris are here today to introduce what their OpenStack infrastructure looks like at Telecom Paris, and some examples of the research projects they're using OpenStack with. Take it away.
Hi, Kendall. Thanks for the invitation. And Mark is here also. So I am associate professor at Telecom Paris. And Mark with me. Can you present yourself?
Yep, I'm a research engineer at Telecom Paris in the networks research group, basically.
So maybe we can go to the next slide that presents the school. So Telecom Paris is a public institution in France. It was founded in 1878. That's quite a long time ago. Well, it depends because we have older universities, but still. And one funny anecdote is that the director of the school in 1904, I think, back then it was Edouard Estonnier. He's the guy that invented the word telecommunication. I think it's a funny anecdote that makes the history of the school. So it's a school of computer science and telecommunication, also member of big French institutions like network of computing science schools distributed around France, especially in Institut Mines Télécom and also Institut Polytechnique de Paris. And we in our school have around 1,600 students and 4 departments, research labs, the first in computer science and networks, second in electronics, communication, and then image data signal, and social sciences and economics also. I have to mention also that Mark created a small center, COSI, Center for Open Software Innovation. And we have, Mark is also, the maintainer of Inkscape, a very big open source project that maybe you know. And we also have the founder of Software Heritage, one of the biggest source code hosting facilities, archive, I'd say. All right, let's go to the next slide to see the infrastructure we have with Mark.
Okay, so I will quickly present our OpenStack infrastructure that we have in our department. It's a fairly modest infrastructure, but sufficient for our needs. We have around 10 compute servers, and more recently, we created 3 compute with GPUs that allowed to spawn VMs with a GPU. We don't really use virtual GPUs. The way we do them is with like PCI pass-through. So we have direct access to the GPU with that method, which might be more efficient, but is also easier to set up, which is why we did it, basically. The way we work, we give one account for one project per research group, so that research group can share the VMs and share the networks, and are allowed to create networks, VMs almost freely, basically. So we end up with almost 80 networks in our cluster. And we also have like lots of space for storing objects and storing images and snapshots, so that everyone can, without too much restrictions to backups and snapshots and store whatever they want in the cluster. And more recently, we also added support for the Octavia and Magnum projects in our infra, which allows people to create Kubernetes cluster. And we are soon in the process of updating to the Xena version so that Magnum works better in that version from our tests. And all our physical infrastructure is backed up by high-speed networking, at least 10 gigabytes, depending on the servers. And next slide, please.
Maybe I will go through the little services we have. So in our department, we use this OpenStack. So we started the OpenStack, I think, a few years ago. Maybe it was 7 years ago, I'm not sure. By aggregating servers and then installing OpenStack. And some of the services we have are used for the faculty. Like Nextcloud is, the alternative of Google Drive, for example, or OneDrive. We have plugins like OnlyOffice that is almost the same as Google Doc or Google Sheets. We also have online courses on Moodle, an equivalent of Overleaf, ShareLaTeX, which is, I think it's the open source code of Overleaf to collaborate on LaTeX documents. We do have a GitLab also, PeerTube for videos, almost like YouTube, Big Blue Button for web conferencing. We use also Matrix a lot with some of the projects, Matrix and Element for chatting. So these are examples of services installed on the OpenStack given to the faculty. Some of them are partially open to the partners outside of the school also. One argument to have everything on site on our own servers is because of the European GDPR. So this is the General Data Protection and Regulation in Europe. So every European citizen has the right to know who is processing the personal data, and also to which actor the data is given, for what reason. And there is also a responsibility of the actors that process these data to notify the users why they do that, for what reason. And we also have in Europe control authorities that have the power to regulate all that and to sanction some of the big companies that don't want to, be precise on what they do with the personal data. So this is one very important reason, I think, to have local services. We are a public institution with public money, as you can see also maybe with Mark behind him. Public money equals public code, and public data, must be protected. Personal data must be protected. Also, we every time there is a good cloud service, we try to find an open source alternative, and we try to install it on our servers, test it, and if it is good, maybe open it to the faculty, so that we avoid vendor lock-in for licenses. And if you collect a lot of licenses, it could be very expensive, and we are a small school, so we don't want to spend so much money on big licenses for software. And if there is an open source alternative, it's a good way, to give the service. Also, the sovereignty of the nation is one aspect. We do use also this OpenStack for research projects. I give a few examples here for future routing architecture for the internet, or for SDN, software-defined networks, or network function virtualization. And also, I know that one of my colleagues is working on low latency networks, 5G and IoT. And I do know that OpenInfra has a project on low latency networks. You were talking about net zero. Of course, green networking is a hot topic now, I would say, in research. And we can go to the next slide.
So we have several ways of using OpenStack. So as Remy mentioned, we can use it to host services that we provide to the faculty. But we must mention that VMs are actually a very good tool for students. Because if you give a VM to someone, they can be root on it and install anything. So basically, they can tinker and try things without any fear of having like huge steps of reinstallation or other things. Because if students contact me saying, "Oh, I crashed my VM, can I have a new one?" I just do OpenStack rebuild VM and OpenStack server rebuild VM, and then 1 minute after they have a fresh VM and a fresh environment, which is very convenient. And the networking aspects also allows us to teach stuff about network environments like Hadoop or Spark projects. And just we can, what we did for a specific course is that we spawned one VM per student in the same small subnetwork. And so everyone could locally install Hadoop and locally install whatever services they wanted, and they were in the same network, so they could do parallel processing within their network. And that was a fantastic tool for us, which allows us to basically get rid of using public clouds for that, which we did in past years, for instance. So by having everything on premises, we were more independent and more free to do whatever we wanted without getting in the subjects of pricing and limitations of some public clouds that were out of what we wanted to teach. We also teach OpenStack itself because it's a private cloud environment that all students in computer science might be interested in learning and also might encounter further in their tech career. So we use DevStack for that. So we have actually VMs in our OpenStack clusters that spawn DevStack projects with an OpenStack environment, which they can administrate, which is kind of meta and cool. And so in that project, they can learn the architecture of OpenStack and the components of OpenStack so that they know what is responsible for what in OpenStack. So they can create VMs and use blocks and etc. and just deploy OpenStack in general. So if I would say there are 3 points to get from our usage of OpenStack, I would say that OpenStack is a great way to provide services to both students and the community within our academic environments, while keeping a total control of the infrastructure. We host everything and we provide everything to students and faculty, which means we control all the data and all the access. So it's very convenient for, as Remy mentioned, data privacy, because we host everything and our few cluster admins have access to everything. On the administration side, the administration and setup of OpenStack cluster, I think, are fairly easy and quite viable at our medium scale of university, which is not a huge scale of public cloud and not a small scale of 1 or 2 servers, which is very easy for us. And also with lots of sub-projects of the OpenStack, we find it is versatile enough to be adapted to every need we encountered so far, from the teaching and tinkering context of students to the production context of having, for instance, a Moodle on it. And that's it for now. Thanks.
Kendall, I think your mic is off still. And maybe some connection problem.
Oof.
Yeah, you're back.
Yeah.
No?
Yeah. Doing things live is great. It's awesome.
Okay. Yeah.
Love technology when it works really. So I was actually wondering what version of OpenStack you're running and how you handle like upgrades, how often you do them for your cluster.
We're currently in the process of updating to Xena, which we should do in probably 2 weeks. And we try to do them in like low activity times. So not exactly when they get published, but quite soon after that. And we stay on Ubuntu LTS servers for the servers that host OpenStack. So we update them every 2 years, basically, and restart them every 2 years. We find that sometimes we have a disruption on services, especially on the network side during the upgrades, but mostly when it lasts less than a few hours, people don't really complain if we do that when they are not actively using services on them. So we try to keep the disruption minimal, and whenever possible, we upgrade gradually the servers and do live migration of the critical services to servers that are not yet in. But we don't upgrade everything at the same time when we can.
Yeah, minimal disruption, especially when you're doing like large scale research processing of data. I expect is very important.
But we try to warn researchers that have courses running on the clusters so that they know that if they provide 1 VM per student, then we won't live migrate everything. We would just live migrate the critical ones, and that's it.
Yeah, that makes sense. Cool. Well, it sounds like Telecom Paris has got a great like OpenStack situation, both using it and teaching it. So I think we'll move on to our last guest today that I've also been working with pretty closely. So Lance Albertson, and actually a couple other students at Oregon State University. So Lance is here today to explain what the OpenStack architecture at Oregon State University open source lab looks like and why they chose OpenStack.
All right, thank you. Yeah, so my name is Lance Albertson. I'm the director of the open source lab at Oregon State University. First off, I kind of give talk about us a little bit. And you kind of think of us as like a free and open source software hosting company. We've been around since about 2003, so well before public clouds even existed. It kind of started within the university IT units with some connections with various open source projects, and it kind of grew from there. But basically, we're part of the College of Engineering currently, and I kind of treat us as like a startup with a university. We are a part of the university, but we're also part of the nonprofit side of the university as well. We offer free and low-cost hosting services for a lot of open source projects. We also offer a lot of co-location services, and part of this calls we offer virtual machines and other cloud services as well. One other unique thing that we do is we provide access to a lot of different kind of CPU architectures. So PowerPC, ARM, 64, and more recently, we actually started hosting some RISC-V systems on some development boards actually in the data center. So that's been fun. We also do a lot of software distribution and mirroring for a lot of projects. You might have actually used some of our mirrors throughout the years. The other part that can kind of mention is that we have undergraduate students that work for me, and they gain real world experience on all of these production systems. So they'll get access to managing all of these things, interacting with the clients, the open source projects, making sure their services are running and everything. And a lot of the past graduates of our program are actually pretty wide spread throughout the industry, and he's actually one of the co-founders of CoreOS was one of our first students. So a lot of cool folks that have gone through our program over the years. So right now it's just me as a full-timer, and I've got about 6 to 10 undergrad students that work for me right now. Next slide, please. So how do we use OpenStack? So the main thing is we want to provide compute resources to open source projects. Most of the times they just need VMs to run some services that they need to do, usually some kind of web service. More recently, a lot of projects want to be able to run some dedicated continuous integration runners, whether it integrates with GitLab or GitHub or Jenkins or whatever type of CI system you use. They just want to be able to do that instead of using whatever shared resources they have. And so before we even got into OpenStack, we use, and we still use today, another project called Ganeti to manage a lot of VMs. We use that more kind of our project or our kind of our pet VMs that we want to keep around. But but OpenStack really provided that API-driven approach that we needed. So that's why we've been using OpenStack. And I think we started using OpenStack in about 2013 and are still using it today. So right now, some unique things that we do is we provide, or how we use it is that we can use OpenStack to provide easy access to the Power architecture and ARM64. So we've partnered with IBM on the Power side and Ampere Computing with the ARM64 systems. This allows us to easily deploy VMs and provide native access on the architectures, or at least near native access, which has really, really been important for those ecosystems. Because some of these systems are at least on the Power side, they're really expensive. They're kind of a pain to maintain. And so, we kind of take that off of everybody, and we can just say, you need access to this, we'll spin up a VM really quick. And then on the ARM side, it's the same thing. We actually have servers that are in the rack, and they're not just Raspberry Pis running somewhere randomly. So they're nice, great systems. And as I mentioned before, these are primarily used for a lot of CI runners and so forth. So a lot of the projects that you see out there, if you see some kind of CI job running on Power or ARM, it might be running on our cloud. We have it out there quite a bit. Or a lot of the software, the binary builds that you see, maybe even Docker or some other things, it might be actually built on our OpenStack cluster, which is pretty cool. Some other use cases is just debugging architecture-specific issues that may happen, whether it's some weird bug that only happens because of that CPU architecture, we could easily spin up a VM. We've had several kernel developers over the years kind of work through that and kind of figure those things out. And I guess I already mentioned about the software binary builders. So we're used quite a bit for a lot of things, and it's been quite interesting. Next slide, please. So our OpenStack infrastructure, we're currently a little behind on our releases. We're currently on Stein. I'm getting pretty close to getting it up to Train. We're a CentOS shop primarily, and our plan is to move to CentOS Stream 8 and beyond. We use Ceph as our storage backend. We actually have two separate clusters. We were able to get, we have one cluster that is for the x86 and ARM systems. And then we have one dedicated one for the PowerPC, since we got it directly donated from IBM for that. And I think between those two clusters, I think the raw data storage capacity we have is about 200 terabytes on each of those. And we're continuing to upgrade those as we can. We're a chef shop for how we manage all of our systems with configuration management. And so we use the OpenStack Chef cookbooks quite a bit. And so that makes things interesting. And then one other thing that's kind of been interesting to deal with is we actually separated all of the various architectures into their own clusters, just to kind of simplify the management plane for a lot of this. That may change down the road to kind of simplify authentication and everything related to that. But that way we can just have everything dedicated. We have no confusion. With x86, we have a variety of hardware that's running on just 12 hypervisor nodes. We can easily expand that. On the PowerPC side, we started with Power 8 systems. Actually, we got started before Power 8 was officially released. We got it on a Power 7 Plus machine that was acting like Power 8. So that was fun getting that going. And getting a lot of OpenStack in the early days, or at least in that time frame, the 2013, 2015 time frame, it was a lot of work to get OpenStack to work on Power at that time, and I contributed quite a bit to kind of get some of that stuff fixed. But as it stands now, we have half running Power 8 and half running on Power 9. We're using host aggregate groups to kind of separate control between those two, and then we just have a flavor that's either P9 or P8. So when people ask for, hey, I want P9, we just say, here, go on the P9 flavor, and I'll get deployed on there. We also have two dedicated nodes that have local NVMe storage. We have some projects that were really needed to have some more high performance IO, and so we have two dedicated systems for that that aren't connected to the Ceph backend. And so that was interesting, kind of figuring that all out. On the ARM64 side, it's a fairly similar setup. We have one controller. At one point, we're going to probably oh yeah, sorry, I'm not looking at my questions over here. Let's see here. What was the question? Yeah, we only use Ceph right now for our storage right now. So we don't use Gluster right now. And that's we actually, when we started this a long time ago, we started with only local storage, and then we had to go through a whole migration process of moving our active VMs that were on local storage over to Ceph, which was very interesting. And we've had some issues with performance on Ceph a little bit, but I think we've kind of worked out a lot of it. A lot of it is just needing to get it on SSDs and kind of expanding that a little bit, but it's been working pretty well. But back to the ARM side of it. Actually, one cool thing about the ARM cluster, we're currently in the node pool for OpenDev. So if you're using Zool to do some of your ARM jobs, some of those jobs actually are going to our OpenStack instance running here on the ARM side. So that's pretty cool. Next slide, please. So why do we use OpenStack? Well, being the open source lab, we want to use open source software as much as we can. And the nice thing about OpenStack is that it's open source and it has a very large supportive community. We can easily contribute back if needed. As it stands now, I'm actually in a PDF of the OpenStack project, or OpenStack Chef project, so that I can help maintain that. We're a little behind on getting on the releases, but it's still pretty active. I'm pretty active in the Chef community itself as well. So we contribute back to the open source community quite a bit. The other nice thing about OpenStack is it provides the API-driven access to all the infrastructure resources. So some of our projects may use Terraform, or maybe use Heat, or some other method of being able to easily spin up and spin down some of their infrastructure. We're actually looking at possibly getting some of the GitLab automation pieces in there so we can just get that rolling as well for a lot of folks. And the nice thing is now that a lot of the hard work has been put in place, it works really well in a variety of platforms and architectures, and it's gotten really stable right now as well. It's been pretty easy to kind of manage it throughout. And I think that's my last slide. I can't remember if I have one more or not.
I think that was your last one. Yep,
okay,
that's the last one. Well, yeah, I love that stability is on there, because a lot of people, back in the day were like, oh, OpenStack, it's so big and complicated and not stable. Well, it is now, and we're here to stay, obviously, with all these research institutions using OpenStack. Yeah, so yeah, OpenStack is now and not in the past. It's here to stay for sure. So man, I totally had a question like a second ago, and I should have written it down because it just disappeared from my brain. I remember. So you've talked about all of these different architectures that you run within the OSL. Is the OSL, or are you specifically involved in the multi-arch SIG that OpenStack has?
No, but we probably should.
Well, I'm not sure if they're planning on meeting at the PTG, but if not, hopefully in Berlin, there'll be conversations about that. It's funny how all of these different SIGs kind of like overlap and touch. You have like the large scale SIG and the bare metal SIG and the scientific SIG and then the multi-arch SIG, and like it's a lot of the same people, but working on different things and having different use cases. Just collaboration. It's so good. I love it.
Yeah. Speaking of collaboration, we are actually working with another unit on campus that does a lot of the biocomputing stuff. And we're going to be actually probably using the Ironic system quite a bit more to provide access to some folks on some of the power infrastructure and the GPU stuff as well. So it's going to be expanding quite a bit.
Awesome. Yeah. Very cool. So I know you mentioned you were behind a little bit in terms of releases. So Chef, I'm not as familiar with like that one for deployment. I know like there's OpenStack Ansible and Chef and Charms and all these different tools for orchestration and that sort of thing. But how are you planning on doing the upgrade from, you said Stein is where you're at right now? So there are releases, obviously. So you got to catch up.
I do incremental releases basically.
Okay.
So I go through each one release, and then I actually build OpenStack on OpenStack, and I'll do a test migration within that. So one thing I forgot to mention is that we use OpenStack for testing our infrastructure quite a bit. So we write our configuration management in Chef, and we have a tool within Chef called Test Kitchen that connects to OpenStack to spin up VMs, and then we can run Chef, and then we can run another tool called Inspect to test and verify everything is there. So I do that with OpenStack. I could spin up a whole test infrastructure on the old system, and then I can flip things over to the new one, and then I can see how does that work. And then if I do things correctly, I can run multiple systems and do multi-node, so I can test the interactions between it, which gets interesting.
That's like OpenStackception. It kind of like hurts my brain a little bit to think about, but if you can keep it straight,
awesome. Yeah, if I can keep it straight, yeah. I have a script that basically does the upgrade, and so it simplifies it a little bit. I upgrade the controller nodes first. And I let everybody know that the control plane is down, all the VMs are still running, and then after I get that upgraded, I go through all the hypervisors, and all of those just get upgraded. The fun part with this next upgrade is going to be we're currently on CentOS 7, and then that's the release that we can switch over to 8. And so we'll have to reinstall all of the nodes from 7 to 8. So we'll do some migrations with that, and I have a separate controller node that I'll be setting up for that as well. So we've been migrating to some bigger systems on the controller nodes because we're running into some performance issues on that. So
getting to the newer releases should help with some of that.
Yeah, we were actually running into some issues where one of the projects, actually I think it was MSys 2, which provides Windows-based open source software tools and so forth, a tool chain. They're wanting to run ARM64 Windows. And with our current version of everything we have on there with KVM and all that, it just wasn't ready. It's like, okay, that's a bigger push for us to get it there. So we're starting to run into issues like that.
Yeah. Awesome. Well, thank you so much for all of the information. I think we'll bring all of our speakers on now. So we'll have the full list of all of people that we participated with today, Remy and Steve and Mark. Yeah, beautiful. Here you go, academia and OpenStack right here, the faces. So I just want to remind the audience, if you're watching us live right now, please throw questions or comments into wherever you happen to be watching this live stream. Otherwise, we have a couple other questions set up. So first one, how does OpenStack allow you to solve problems with educational institutions needing access to newer or more advanced resources? And I have this question for basically everyone. So I don't know who wants to go first. Steve, would you like to go first? We'll wake you back up since it's the middle of the night for you.
Sure. I'll answer before I fall asleep. Yeah. For us, the answer is yes, and the way we do it is we have an evergreening program, and so we call it an incremental refresh. And so every year we're sort of removing some of the fleet and putting in a new fleet, and that gives us that chance to ask the researchers, or they may have money themselves, to what equipment they really need. And so that's how we make sure we're just perpetually always getting new equipment in. And those new resources in place. The really interesting dynamic we have at the moment is our OPEX is quite stable, other than that energy electricity problem, which comes back to the topic I brought up in the talk.
Did anybody else want to answer the question too?
Yeah, maybe I would like to suggest all academics to prefer teaching OpenStack rather than Amazon Web Services, Google Cloud, Microsoft Azure, I don't know what. Because it's open source, you can look at the source code to learn how it works.
Yeah.
With others, you cannot.
Yeah. You have a lot more fine-tuned control over every aspect of your cloud because it is open source, and you can, deploy it however you want. Yeah, I support this. I love working with universities, obviously. Telecom Paris, I work with Lance at Oregon State University. I also work with a professor and students at North Dakota State University every year, and also Boston University as well. So more universities.
I think if I can add something here, I think the So in terms of new hardware or new advanced resources, I think that the easy one is in the software domain, and I think OpenStack really enables us to innovate in research computing in the software platforms that we're using. And when we start to think in this more sort of cloud native way, we get this much more rapid progression in academia for the kind of software that we're using. We do. I mean, that isn't to say that we can't use OpenStack for access to exotic hardware as well. And but quite often when we do that, we get a resource that is contended. You know, everyone wants to pile onto the new kit, and so therefore we get this really interesting and fairly novel problem in cloud, which is there is a finite size to the infrastructure that we are exposing and making available. You know, I guess the public clouds, they like to present this illusion of infinity, you know, and it's kind of deceptive. But that's in a research computing environment, we're very much the other way around. We want to maximize the use of a very finite resource, and that brings about a whole lot of innovation in terms of how do we share that, how do we manage this contention and the sharing, and that it's a whole other discussion really. But it's something that within our team we call it the coral reef cloud. If you think of like the corals on a seabed and how they compete for space, and there's brings in a lot of other interesting discussions around reservation and preemption, and just sort of pushing people out of the way with higher priority. It's an interesting place to be in.
That's very interesting, because I remember last week, Mark, I asked you, well, I exploded my quota for the project, and I asked Mark, could you add more instances, for example, but indeed, I don't know. Yeah, that's a very good question especially for net zero.
We had this problem really early on where people were given rights, allocations, and they would hoard them. They would sit them there and save them for a rainy day. They weren't doing anything. And so we ended up having to deal with this people problem type of thing, and made it so every allocation only lasts a year. And like, so things are solid services that run for 10 years, right? They're fine, but in principle, there's this idea that resources are finite, and you have them for a period of time, and if you don't use them well, it may change on you.
If you don't use it, you lose it.
Yeah.
Yeah. Well, unfortunately, we are out of time for today, but this was such a good discussion. I'm so happy that you all were able to join us. Thank you so much for sharing your insights and wisdom, and like all of this inspiration about research being done and collaboration between universities and all kinds of organizations. It's so good. Gives me the warm fuzzies. So as you hopefully already know, we are bringing the OpenInfra Summit back this year, and are also headed to Berlin in Germany, obviously, June 7th through 9th. And the summit schedule will be available next Tuesday on March 8th. So make sure to look at what exciting sessions we have planned, and don't forget to get your tickets before prices will increase on March 18th. So many numbers. And speaking of the summit, we'll have another great episode of OpenInfra Live coming up on March 17th to talk about some of the 5G, NFV, and also Edge sessions that you definitely don't want to miss at the OpenInfra Summit in Berlin. So you have the 17th, 18th, and March 8th as well. Lots of dates. Also, note that due to daylight savings time changes, we'll start all future OpenInfra Live episodes at 14 UTC instead of 15 UTC. Unfortunately, the world is not flat, so we have to deal with these silly things like time zones, especially for poor Steve. Also, remember that if you have an idea for the show, we want to hear from you. Submit your ideas to ideas.openinfra.live, and maybe we'll see you on a future episode. Thanks again, everyone, on today's panel. We are OpenInfra.
Thank you.
Thank you.